So I'll be completely level with you. Until 2 days ago, I didn't have a talk. And so I saw my slot in the schedule. And what I had was not working. A plan B. So I had a plan B, which was, I'll show you this slide, right? I'll dim the lights, if possible, in this case, probably compromised. And I'll play this music. And I'll wait 5 minutes. And everyone will be out. So fortunately, I geared up a bit, and I can now switch back to plan A, which is a talk about, I guess, functional programming. So when you talk with people about what functional programming is, it's actually remarkably vague. Everyone knows what they mean, but it's really hard to put a definition on it. And actually, I met the organizer of the functional programming meetup in Berlin at a party on Friday. And she said herself they had a whole meetup on that very subject. And basically, the best they could come up with was, well, as much as possible, like Haskell. So, yeah. So, so what you could say is that, well, it's related to lambda calculus in a way. Lambda calculus was invented by Alonzo Church at the same time as Turing was coming out with his Turing machine. And lambda calculus, just like the Turing machine, can be used to describe pretty much any program we can run. So the difference, I guess, with functional programming is that the syntax is actually closer to the notation that Church came out with originally, and it's not an accident that this is the symbol for closure representing a lambda. Okay. So what is it practically? Well, it's all functions all the way down. So your program is running a function which runs functions, and that's it. There is no global state or no global variables. So obviously, like all good JavaScript programmers, you'll nod and say, yeah, we don't use global variables, that's really bad. Except we kind of do, because when we use console, or we use document, or we use window, we're obviously using something that is not explicitly in the context of our function. Relatedly, no side effects. So basically, you're not technically allowed to do a console log in your function, because that's like kind of veering away from the straight path from input to output, which your function is supposed to follow. And no destructive updates, which may prove to be the hardest thing to work with, so because it means you cannot change any variables. I guess you can return something different, but yep, basically that's it. So who can point out what's non-functional about this example? Not good enough. Yes, so the side effects, console log, is obviously wrong, but also the fact that in the sayGender function, you're using data that comes from outside your function. So you shouldn't actually be using that. Obviously, this is not an example of functional programming. So some patterns. So actually, JavaScript is pretty good because it's got obviously functions as first-class citizens, and so you can create them and pass them around and everything. So everyone uses higher-order functions, whether they realize it or not. One form of higher-order function is taking a function as argument. And obviously, we all do that. Callbacks of any kind, event handlers. This is all taking functions as arguments. Then there's returning functions. So we have functions that return functions. And actually, if you've been doing JavaScript for a little bit, you're probably doing that as well. This is like loosely based on a project I worked on. And like one of the things we did was define like a more general validate function, which would then call, which would then get passed in the actual thing to validate, the actual function to validate. And so you could define more precise validation functions by passing in functions that would actually check your values later on. So you can see required field gets a function in, and sorry, I'm a bit confused, and returns whether there's an error or not. So that's an example of validate outputs a function which you can then use later on. So utilities, things you'll use quite a lot when you're doing functional programming. Map, so when you do map on a collection, or filter on a collection, or reduce on a collection. So out of the box, JavaScript doesn't have anything very functional as such, because what you've got is basically something defined on the array prototype. But there are libraries out there which will express things in a more functional way, like _JS, or slightly more esoteric ones, like this functional one I found. So basically you can start throwing out some things you may use on a daily basis out of the window, like for instance the for loop. So for is actually, it's not very functional, and it's also fairly clumsy because it actually combines three things. So you could use a for loop to go over a collection, and that's basically the same thing as doing a map. Or you could do a for loop to basically only change certain elements. That's basically like doing a filter. And then you might want to calculate an end result by going over a collection, and that's just like doing reduce or left fold, like the functional types call it. So yeah, the for loop is already pretty ugly to start with, because it's like straight out of C, but it's also not super good functionally. So we're ramping up slowly. The difficulty started with very easy and going a little bit harder. So currying. So currying originally in Haskell is like the concept of you take a function with several parameters, and you can kind of decompose it in functions that take one parameter each. So you run basically your function with a first parameter, and then you add your second parameter, and every time you output a function until you have the function you actually basically want to use. And well, toy example here. So I see actually I have a bug already, but so say you have a very simple function called phone listing. If you try to run that with just one parameter, you'll get undefined. In Haskell, this would actually work. You can just take a function, pass it one parameter, and it will know you want the function back to actually continue working. You can kind of fake this in JavaScript as well by, for instance, defining a partial function, which will take your original function and any number of arguments you want to pass it. And with a little bit of magic, it will return a function that has already applied those first parameters. So again, to go back to the toy example, say that Sam actually changes his phone every month. You can decide that basically you want a function for just Sam's Sam's phone number. I see, actually, my original example involved girlfriends. Sam's girlfriends. So no, it's Sam's phone number. And you can define a function for just Sam's phone numbers and just use that. Does that make any sense to you? Yep, it's not too hard, I guess. Okay, monads. So monads, monads is one of them words that make people's brain dribble out of their ears just by hearing it. So I actually want to talk about yogurt. So I'll tell you a story about yogurt. So where I work, we have this cafeteria where we can have free food. And there's a big fridge where you have smoothies and yogurts and drinks. And there's this particular type of yogurt, which you see here, the brand name hidden for you, which actually is like the most unhealthy yogurt you've ever seen. It's like toffee flavored, and it has bits of biscuit in it. And there's a very limited supply, so they're immediately gone. And so, right, I'll do the multiple choice thing now. So you remember those books you used to have as a child, where they said like, right, if you want to fight the dragon, go to page 55, or if you want to flee and run away very, very quickly, then you go to page 102. Yeah. Well, we can skip the monads, or we can do the monads. It's up to you. So people who want to do the monads, okay, let's do the monads. So, right, yogurt. So, basically, the thing with the whole story around yogurt and monads is that things are named pretty badly. So it's normal that people don't understand things the first time around because it's really not that well explained, I think. So basically, with monads, you create monadic values. What is a monadic value? It's basically creating a function which will enclose over a state or over a value. And that's it. It returns that function that when you call it, it will return a value. This is actually the simplest function, the simplest monad you can have, monadic value, sorry, you can have, where it will just return the value you just passed in. So you create a function which, when called, will return the value that was originally passed in. So it's not that complicated. And you can make it return a structure that contains a little bit more, like for instance, now the state, which is the number of our yogurts, very important. So to illustrate, so we make a monadic value containing the value Joe. Joe is in the kitchen watching the yogurts. And you pass in the number of yogurts you have originally, 10. So to go back here, so you passed in Joe in the value, and you passed in 10 in the state. So what you get is this. So far so good, right? Yep. Cool. So now you want to start making the story evolve as such, because Joe and the yogurts, you know, it's not moving much. So what you're going to do is to bind that monadic value to a function. And that bind action will itself return a monadic value again. So you can kind of continue chaining the story. So it will also apply the function to the original value you passed in. As you see at the end, basically you pass in the original function, and it will apply on the original value. So you return again a function doing something with the state. Does it kind of make sense, or do you want to? Yep. So, okay. Tom comes into the kitchen. We want to add a person. So in your normal everyday kind of scripting, you would probably do the function above there, which is saying, well, whatever we had plus the new person. Well, here's the monadic way to do it. So you pass in the monadic value and a new person that just walked into the room. And you do a bind. Again, returning a monadic value, adding the new person there. So this is basically what happens. You do add person with the monadic value and Tom, who just walked into the room with Joe. And now we have Joe and Tom and 10 yogurts in the room. But not much yogurt is getting eaten so far, which is a good thing. And so you want to start working on that. Act on the state part of your equation. So you're going to define take yogurt. And take yogurt will do a bind of the monadic value and a function, which will again return a state function. A function with, state as parameter. And will act on the state. So it will take one yogurt out, state -1. And so if we run the take yogurt on the original states with Joe, then we have value Joe and state is 9. Okay, so far, still. So basically, in this way, we can construct a long story, a chain of events, which will be applied one by one. And it will be applied in order. And you can construct a coherent story with, like you can see a state, the 10 yogurts. And it will lead to a coherent result without ever using like variables that you change. So it's actually really a purely functional way to do what you've been doing, or what I've been doing as well, with objects and variables, but just using pure functions. So that is what yogurt is about, really. And I really recommend. I recommend looking into it if you're interested. And there are all kinds of monads. The one I talked about was a state monad. But I really recommend this presentation, which is like excellent and explains it with closure, but in stories. So it's not like completely hardcore. It's actually really well explained. So one thing that is often associated with functional languages is also lazy evaluation. So lazy evaluation, you think of an infinite kind of, how can I say? I guess Stream.js has been talked about here. Stream.js allows you to, for instance, define the range of natural numbers and work on them and not calculate them right away. Now, I put a question mark there because I'm not sure lazy and functional, I think they may be orthogonal because you have eager and lazy functional languages and eager and lazy non-functional languages. But it's definitely an interesting thing to look into. So what's good about functional programming? It's easier to debug because when you have a stack trace, you find your function, you find out what the input and the output is, and you can actually exactly reproduce what went on because there is no things being passed in that function or no things being done in that function outside of what you give it. So input and output, and then the point in the stack is all you need. It's easier to test because you can, again, count on the fact that all you have to test is input and output. So you put your input in a function, it gives you an output, end of story. That's what you test. So it's also easier to refactor because, again, like what matters is the signature of your function. So if you don't change the signature, you can basically butcher the internals as much as you want because the outside world will only see the signature. And some people say, again, that it helps for parallelization. Now, I think what's more important for parallelization is using the right concurrency primitives. So I'm not 100% sure that parallelization, functional programming is like all you need. But it may help because at least you know there's no global shared state there that you should like, that you will have problems with, like Heisenbugs or whatever. So is functional programming, I'm glad it's stopping raining, or no, it doesn't. So is functional programming hard? So I feel it is. And actually, I would recommend you to try purely functional languages, because if you use just JavaScript or whatever you're used to using, it may not force you to bend your mind in the ways that will help you do functional programming. So I would encourage you to dip into Clojure, or even better, Haskell. I've started to look into Haskell, because people who are much smarter than me ensure me that this is actually the only way to really, take on the right kind of patterns in your head. So, okay, so I've been around for a while in programming. So I'm going to do a little rant, a little bit. Okay, functional programming is not new, right? I mean, there was Lisp in the 70s, and back then that was the bee's knees and the best thing ever invented. And then object-oriented programming came along, and suddenly that was all the hype. Everyone wanted to do object-oriented and Java and everything. And so you kind of get what I mean, right? Like, programmers are like this, right? Programmers are kids in a candy store. Basically, they get a bit bored, with the daily routine, and so they spot something new and shiny, and they basically run towards that new thing, and which is very understandable. But the core of the business is that software is hard. Software of any size is hard. You'll have human error. You'll have problems. You'll have, working with different people. And what you need is taking a step back and thinking. Whatever paradigm you use, if you don't apply it well, if you make mistakes, and if you don't double check yourself, then I'm afraid functional programming won't help you. And so I'm always a little bit skeptical about the new best thing that came along. However, it might help in some ways. And to be honest, I'm in the same situation that basically I'm also always interested in what's new and shiny. And so I kind of get the excitement, and I can also kind of get that there may be advantages when applied really well that make functional programming a really good thing to do. So thank you for your attention. So
questions?
Questions? Yeah.
So if I understand stuff like the way the monads are implemented, like in your example of how you do it in JavaScript, it seems like that in that particular case, you're always returning new objects, right? So it's creating new objects every time you return from one of those state mutations. Is that right?
Yeah, I guess the essence of it is that you don't return anything until you actually run the function.
I see. So it only ever has one object allocated. It never allocates more.
Well, I guess it goes kind of through the thread, but eventually, yeah, it outputs one object. Yeah.
I see. Okay. Yeah, I guess my larger question is, you know, I assume functional languages like Haskell or Clojure are like really optimized for doing these kinds of things, whereas I would assume JavaScript isn't necessarily optimized for doing it. So do you know, like the kinds of patterns you showed, are they typically relatively efficient in JavaScript? Or, I mean, obviously things like map and whatever are fine, but like monads or some of these more advanced things?
Yeah, so I think like what I showed was obviously a handcrafted thing, and there are libraries out there that allow you to have some syntactic sugar. And also I expect that if JavaScript evolves in the direction of being more functional, you might have more inbuilt syntactic sugars, like a better syntax for lambdas, for instance, so for anonymous functions than you have now. But yeah, so look into libraries if you want to apply such things, I think.
So I like functional programming, and I'm happy you're talking about it. But it's actually a little slower than if you just do mutations and mutate everything around. And do you have any strategy how we can make JavaScript engines optimized for functional?
Well, I would recommend reading purely functional data structures. Like the really functional languages, so like you say, you never mutate anything. So basically, you duplicate any data structures you pass around. So that may have a cost in memory. So what the functional languages do is like they share these as much as possible. So if you grow an array, they'll reuse the array that is already there, and then. Sorry? It does it already. Yeah. So I'm not that well informed. It's not. Yeah, exactly. Well, again, like one would hope that if it goes more in that direction, that people would start hacking on that as well. Yeah.
Okay. Thank you, Elise.
Thank you.